over this free response question we did yesterday in class, just to show you the rubric. So we did this yesterday in class. It was find the area of region R. So we had an upper curve, and we had a lower curve. And the upper curve was that sine curve, and it was the upper curve for the entire width of the domain. So the whole width here, this is always above, and this is always below. So we had then that integral of the upper curve minus the lower curve, okay? And then we were able to do an FN to get 4. So if you notice the grading rubric here, you get a point for appropriate limits, a point for the appropriate integrand, and the appropriate integrand means we have an integral symbol, we have a dx, we have the functions in the right order, and we have all our appropriate brackets, okay? And then an answer, a point for the answer. You notice the answer here does not include units. I think most of us were putting unit squared on that. That's always a good thing to get in the habit of doing. Unit squared will always be accepted if there's nothing specified here. So I think it's just a good habit to acknowledge that we're dealing with area, and area always has some sort of unit squared. And then that bottom part, I can stop moving around so much. I guess I can't really get the whole thing on the screen. That bottom part was that line at y equals -2. And this is the interesting thing. We had to do a second calc on our graphing calculator to get those points of intersection. And if you notice, this was 0.539, and this was 1.675. Okay, and this is what they did down in the rubric. They defined those as R and S. And then if you notice in the integrand, let me scroll up now. In the integrand, they just put the variables R and S in there instead of putting the numbers in the integrand. So, and the College Board lets you do that. If you want to define, since those decimals are kind of long and they don't terminate, if you want to define this is R and this is S, and then refer to R and S in the integral to make it look cleaner, go right ahead. Okay? So they had the upper curve -2, the lower curve is the cubic, and then they put the integral, the limits there. So the correct limits with their values, and then the integrand, the integration symbol, the appropriate brackets, and the dx. Okay? So that's kind of how that grading went. All right, and we didn't do this one in class yesterday because we kind of didn't have the time to, but that's just another example. That's just another example of finding the area between two curves. So we can see an upper curve minus a lower curve. I just want to point out, this is actually a no calculator problem. So, you know, they're asking you to do some calculation, to do some integration of trig functions. Okay? So cosine of pi over 4x is 4 over pi out in front. That's the u sub sine of pi over 4x. Okay, so they will expect you to do that by hand as well. Okay, so questions about that? Okay, so far so good. Okay, so one thing I've noticed about some of the homework is it's taken a little longer than I anticipated. So some people are putting like well over 60 minutes. I think 60 minutes is pretty reasonable. You spend 60 minutes in class, spending the same amount of time doing homework is actually a pretty reasonable expectation for an AP class. But some people are spending a lot more than 60 minutes, and I think it's because a lot of the answers are requiring you to answer exact answers. Okay, so I am trying to change some of the settings so that decimal answers are okay, and hopefully that will correct some of the problems. I do notice though that some of you you have repeating decimals and you put it in as a repeating decimal. Like you had 19.33333333. Try putting it in as 19 and a third. Okay, instead of the 0.33333, and I think it'll mark it correct. But I am in the process of trying to change those settings so that decimals are okay. Okay? So any questions on the WebAssign? I just know that I felt like I needed to address that one specifically. Okay. Keep up. We're in the home stretch here. Okay. Try not to let it lag too much here. Okay. So boundaries with changing functions. So here's the first task at your table. We have this region here. We start at what value for x? 0. We end at what value for x? 4. Okay. So the question is, I want to find this area, but there's a point at which the upper or the lower curve changes assignment. Like for instance, from 0 to 4, what's my upper curve?
Square root of x.
Is it always my upper curve?
Yeah.
In other words, everything always below it? Okay, how about my lower curve? Is this the lower curve from 0 to 4?
No.
No, it's only the lower curve from 0 to
2.
2. And then what's the lower curve?
X minus 2.
Okay, so come up with an expression, an integral expression, okay, that will be able to find the entire area in orange here. Are we going to be able to get away with one integrand? Gut feeling? Yes or no? Okay, so at your tables, just take a second. Let me try to get that a little higher on the screen. There we go. Come up with an approach there. Okay. What does that look like?
What do you think?
Here? Okay. Do you want to use mine in the meantime, or? No, that's okay. Okay.
She lives down the street, she'll literally be here like a minute.
Okay. Right down Michigan? Seriously? So you live really close to Sanger?
Yeah, I live in the other direction.
Oh, okay. So, can we go all from 0 all the way to 4? We have the same lower and upper. Awesome, awesome. Just dress this up with another set of brackets and a dx, just to make the graders happy. Yeah. Boom, boom, and one for each of you. I mean, just to cap all that off, and that looks fantastic. I'll put that on the board. Well, let's take a look at this one. Upper curve all the way from 0 to 4.
All the way up until
Is this 0? Is this
She always bacon. She always makes bacon. It's just good.
just get a pen, let you think, and a back. So we know that this is the upper curve, like from 0 to 4. Okay, so from 0 to 4, is this the lower curve all the way back to 0? So this orange.
Oh, yeah,
is
yeah,
this
that's
from the
much
curve
better. I think
goes
that's
all the way
better.
back to 0? Okay,
Yeah.
because it would be down here, right? Do you want this area down here? No. That would be appropriate. I agree, that would be appropriate from 2 to 4, that would at least give us this, right? Now, how do you get this?
You use it to label it.
What's the upper curve, what's the lower curve?
But in parade, it's drum line. It's between
Molly's giving us an approach here. Okay, so there we have our approach. All right, so here's the tricky part. I got a little tricky with it. You see what I did? Just to simplify the brackets. We talked about yesterday that if we're going to integrate 0, that's not going to have any area underneath it, so we can just drop the 0. Does that make sense? When I distribute my minus sign, I get my minus x plus 2. Okay. So go ahead and integrate that by hand. We'll practice this by hand thing. Okay, so no f-ints. I'm going to do the integrating x to the 1/2. Bump up that power, divide by that new power. Awesome. That's totally what x to the 1/2 is integrated. That looks great. You got it. Yep, those look great. I think we need to have a plus sign right there, though. Oh, gotcha. That was just the first integral. I got it. Okay. Okay, so we're pretty good with the f-ints, but now we need to be able to integrate that by hand. Definitely need to do that. Okay. All right, so I'm seeing that as the integral for x to the 1/2 on lots of papers. So there's the first integrand integrated. And then we have I see that on a lot of papers. From 2 to 4. Okay. So just an exercise in integrating that. At this point, I'm not going to make you stick the 4 and stick the 2s in and do a whole lot of math. But I thought I saw some. I did see some f-ints, right? What was the f-int for this one? Anyone have that first piece? Nobody has that first piece? I thought I saw some f-ints. Does anyone have an f-int for this last piece? Did anyone just do the f-ints instead? Just do the f-int here and get the answer? The value? Do the f-int here? Nobody did? Okay. And I'm not too concerned about it because I know you know how to do f-ints, but I did want to go through the integration, okay? So from there, we could calculate the answer for that area, okay? So we're just going to go ahead and go on to this. Okay, so this is the other big piece that sometimes occurs, okay? Integrating with respect to y. if we look at these things, we don't really have an upper and a lower curve. We have something that looks more like a what and a what. Instead of an upper and a lower, we have a left and a right, exactly. Okay? And so when we have these left and rights, a lot of times it's easier to write them in terms of y. And so the same approach applies. Okay? When we did upper minus lower, we got the area because the upper was the bigger. Which one's the bigger one here horizontally? Is it the left one or the right one that's bigger? The right one. That is the bigger x's. Right? Our bigger x's are over here. So we're going to take right minus left. We're going to take right minus left in terms of y. Okay? And we can accomplish the same thing. So if we look at this problem, if you notice, we could really call this the right curve. And we can really call this the left curve. Okay? But we have to write them in terms of y in order to do this. So that means taking this and calling it y, okay, and then solving so that we are writing it in terms of y. So let's call this function y. Okay? In other words, I'm just going to write it like that. You know, that looks like a line, right? Slope-intercept form. Okay? I want to solve this now for x, which means I got to get x by itself. So how do I solve that? Add 2 to both sides. And so what do I have then? X equals y plus 2. Okay? So now I have a function in terms of y. Does that make sense? It's y plus or minus, or it's y squared, or something like that. Okay? Now I'm going to express that back in my function notation. In other words, this equation, y plus 2, I'm going to call f of y. I'm going to call it f of y because it was the one that was farther to the right. It was the bigger one, horizontally. Does that make sense? Okay. Let's go back up to this one. Write that one in terms of y. What does it look like? Yep. Y equals the square root of x. Now let's how do we solve here for x in terms of y?
Square both sides.
I have to square both sides. It's a sideways parabola. So x equals what? Y squared. Exactly. X equals y squared. That's your sideways parabola. That's one of these things. We're just looking at the top half of it. Okay? Express them back in their function notation. So this is going to be y squared equals g of y. Okay? And so now we have those two functions. So if we look at this, I'm going to try to draw this from memory. We have this. We have here. That. Does that make sense? And then we did have this lower function. This lower function just becomes a bound. If we're going to use this as our right function, this is our f of y equals y plus 2. And this is our left function, g of y equals y squared. Notice that the square root signs went away. So this is going to be a lot easier to integrate. If we're going to accumulate the area in the y direction, because we have y functions, Just like when we had x functions, we were accumulating the area in the x direction. If we're accumulating area in the y direction, we're starting at what value? And we're ending at what value?
2 squared.
So we're starting at 0, and we're ending at, is that 2?
Yeah, it's 2.
We're ending at 2. So what does my integral look like? 0 to 2. Now, from 0 to 2, is this function always on the right-hand side? So it's always the bigger function. Is this function always on the left-hand side? So it's always the little function. So we can take our big function, y plus 2, bless you, and subtract our little function, y squared. dy, exactly. How many are comfortable with integrating y's instead of x's? We okay with that? It's just, we're doing the same thing, right? We're just writing down a different variable, literally, okay? But how much cleaner is that to integrate than the one before? Right, the one before we had an x to the 1/2 power, and we ended up with a 3/2 power, and then the room got really quiet. Nobody really wanted to do anything with it, even with an f int. Okay. Understandably. So sometimes it's easier. I've got a y plus 2 minus y squared. I'm just going to simplify the brackets a little bit. Sometimes life gets easier if we just kind of turn the page 90 degrees. Okay? And it's your choice as to whether or not you want to do that. So what's the antiderivative of y? Just y squared?
Well, times
Yep, divided by 2. What's the antiderivative of 2? 2y. What's the antiderivative of y squared? Y to the 3rd over 3, just like we would do with our x's. Between 0 and 2. Is plugging in a 2 now not a big deal? All right, we put in a 2 here, we get how much? Yep, 4 over 2 is 2. We put in a 2 here, we get 4. Those are nice. We put in a 2 here, we get, okay, it's a fraction. We'll deal with it. And then we plug in zeros everywhere, and we just get a big fat old 0, right? 0 plus 0 minus 0. So I've got 8 minus 8/3. Units squared. Okay.
6 minus 8 thirds.
Wow, yes it is. 6 minus 8/3. Doggone it. Sometimes the simple stuff just really is hard. 2 plus 4 is not 8. Okay. So how many think maybe learning how to turn things 90 degrees might be a little worth it? Okay, there is one homework question that has you spin these, that gives you everything in terms of y instead of in terms of x, so that you can work on that. If we take a look at just a quick peek at this free response, if you notice, this is always, if we tried to do this with x's, we'd have to split it here because then we have a function change. But if we do it all with y's, then this is always on the right and this is always on the left. So can anyone tell me what this function is? Just reading the instructions here. 5 minus x. So we know that this is, I'm going to call it f of x because it's farther to the right. It's 5 minus x. So what is this function then? Just doing the reading. Natural log, yep. So this is my g of x, my natural log of x. Okay. What are my limits going to be?
0 to 1.
So I'm going to start here, and I'm going to end up is that 1? It's where those two are equal, right? Yeah, graph it and find the intersection. Hey, I know, let's call it A for now. And then we're gonna do a calc intersect and we're gonna say A equals something. Okay. So I'm gonna give you a second to let me know what A equals after we do a calc intersect. Again, if you're looking at your graphing calculator going, I just don't remember how to do a calc intersect. Now's the time to ask me. I can show you. All right, we can get those things out of the way here while people are working on that sort of stuff. Okay not to know how to do those things. It's not okay not to ask. I got some stuff failures over here people need on. You get a graphing calculator, right? Okay, so you did your calc intersect, right? Okay, so it's asking you to select the first curve. If we notice here, so eventually we'll start to see a little cursor. There it is. Okay, so hit enter. And you just selected the line. Now it automatically, if you arrowed right and left, it automatically jumps to the other curve. Okay, so hit enter again. So now you selected the LN. Okay, and then you're pretty close to the intersection, so you can just hit enter for your guess. And there it is. Yep. So it's 3.693. Okay, so we've got this at 3.693 comma 1.307. Okay, so we are looking at then, I should have more space near the picture, although we should be putting things in the answer area, but so we are looking at then an integral from where to where?
0 to 1.307.
Yep, I'm going to go from 0 to A, and I'm going to somewhere over here say let A equal 1.307, and I'm just going to go from 0 to A, and then what do I do here? You know I need my larger function minus my little function, big minus little. But big minus little in the x sense, okay? Which means we've got to take these and solve them for x equals, right? I had a really bad mistake there. That should be a dy. Okay? So, let me try to move this with my calculator. Oh, thanks, Tim. Let me try to. So this gets to be. So we had y equals 5 minus x, right?
Yep.
So what is x equal to?
Negative 1 plus 5.
Okay. Yeah, take the, in fact, wow, maybe I should write that the other way. Take the x over 5 minus y. Yeah, I agree. If y equals natural log of x, right? That's what the other one was. And I have to solve that for x. What do I have to do to both sides? Algebra 2, pre-calc stuff here. Want to solve for x, what do I have to do to both sides? Yep, exactly. Exponentiate it. Raise it to the power e. This is how much?
X.
That's just x, right? That's your identity. X equals e to the y. Okay, so we know that this is our bigger function, right? So this is our f of x. And this is our littler function, it's the left function. So this is our g of x. G of, wow. Yeah. This is our x, which is our f of y, function in terms of y. And this is our little function, our smaller function, which is our g of y. There we go. So now we can put those in here. We have e to the y, and we have 5 minus y. Okay. And I think it just says set it up, right? Oh no, but it's a calculator. You could do an fint on that if you wanted to. Okay. Natural log would be like the most complicated they would give you. All right? Is that okay? Okay, so this last page here is just telling you what the homework is. I took the passcode off, so we should just be able to get into the homework. Just a reminder, Blackboard quiz tomorrow, going over the test tomorrow from the last unit. That's the focus for tomorrow. And then after you get your corrections done on the tests, any extra time is just left for WebAssign for you if you need it. Stay current, please. Okay. We're in the home stretch. It's so close I can almost taste it. Like we just got one more week of content. Then our last test. And we all take a big collective sigh of relief because we have spring break. Okay? Okay, so we want to find that function, right? So it's in second. Is that the function? Second function. And then it's going to ask you for two curves. Okay, both functions. So it automatically snaps to one. Just hit enter. See how it jumps to the other? Just hit enter again. It's just selecting the two things I want. And then a gap. So we're going to arrow to the left just a teensy bit to get close because it'll.
On the other side of the.
It doesn't matter. You just want to get close.
And how we don't have to. Yeah, we could.
So there's my 3.693 and my 1.31.
I think it's a lot easier.
I wrote those down, you know. Sure. I only have the calculator part of the history.
We had to first figure that out. How do you put it in your calculator to figure out how to graph y?
Like if you want to do an fint?
No, like to figure out, because for one sign we have to graph it.
I don't know. Give me just a second. Not a function, right? So we have to split the two. If you count the points,
See what you brought.
So we have to graph.
you do. This will let you graph a sideways graph.
No, I know, I'm like doing that right now, but I don't know how to, where it goes.
Okay, so we know that 0 is 0, right? Where's your graphing points? If we had a y value of 2, right? Yep. So just put a point there. There you go.
Okay, then there's y plus 120. There, and then it would be like 222.
There you go. There it is.
One with without I.
Okay, so now
Yeah, that one is.
Give him a headphone so we can hear the girls screaming. Give him a headphone. Give him a headphone.
I didn't know.
He's so polite about it though. He's like, alright, if anybody's squeamish.
So this would just be a peer.
And then 20 seconds.
You can skip all this. It's just him. Oh, no, don't get too far.
CV mail.
This, you can start.
All right, what can I help you out with?
But you
You
did.
sent on the